Good morning, students. That is, last class we discussed about the P block elements, and you please note down the major questions from group 15. We already completed group 15. That is the first one. First question: arrange arrange the hydrides of group 15 in the increasing order of two factors. First one, increasing order of basic character, then reducing character. That is question, or otherwise, which is the correct order of basic character among the hydrides of group 15. And first of all, you have an idea about the hydrides of 15th group. I already told that group 15 elements combines with the hydrogen to form hydrides which are isostructural with the ammonia. That is NH3, PH3, ammonia, phosphine, arsine, stibine, bismuthane are the hydrides of 15th group. And among these, three factors: thermal stability, bond angle, basic character. These three factors are maximum for ammonia, and the reducing character is just opposite. Bismuthane is the most reducing hydride because BiH bond is weaker, or in other words, NH bond in ammonia is stronger because of the presence of intermolecular hydrogen bond. And the correct order, maximum NH3 least BiH3, the order revert here. And second one, nitrogen do not form pentahalides, or NCl5 does not exist. What is the reason? Nitrogen do not form pentahalide, or in other words, NCl5 does not exist. It is due to the absence of d orbital in nitrogen atom. Third one, dinitrogen means N2 is chemically inert at room temperature. Dinitrogen is chemically inert at room temperature. What is the reason? Dinitrogen is chemically inert at room temperature because of high bond enthalpy. Means there exists N triple bond N. Large amount of energy is required to break the bond between two nitrogen atoms. Suggest a method for the preparation of pure nitrogen. Pure nitrogen is prepared by the thermal decomposition of sodium or barium azide. Then how nitrogen is prepared on a large scale, or manufacture large scale production of nitrogen by the fractional distillation of liquid air, which contains mainly dinitrogen and dioxygen. Dinitrogen distills at 77 Kelvin, leaving behind dioxygen. Then suggest the condition to get, suggest the conditions to get maximum yield of ammonia according to Le Chatelier's principle. According to Le Chatelier's principle, the condition to get maximum yield of ammonia are high pressure, that is 200 atmospheric pressure, low temperature because the forward reaction is exothermic, however an optimum temperature is used, and lack of d orbital, non-availability of high pressure, 200 atmosphere, optimum temperature. Actually forward reaction is exothermic, therefore the increase in temperature shifts the reaction in the reverse direction. But low temperature combination of nitrogen and hydrogen does not take place, therefore an optimum temperature 773 Kelvin is used, and the presence of catalyst, that is the third factor, presence of catalyst, spongy ion supported over molybdenum act as catalyst. Then ammonia act as a base. Explain with example. Ammonia act as a base, or ammonia act as a Lewis base because of the presence of lone pair of electrons on the nitrogen atom. It can donate electron deficient compound to form complex or even addition product. Lewis base, electron pair donor. Then nitrogen forms a series of oxides in which the oxidation state of nitrogen changes from dash to dash. Nitrogen forms a series of oxides in which the oxidation state changes from dash to dash. That is, nitrogen forms nitrogen 1 oxide. Nitrogen 1 oxide, it is called a nitrous oxide or laughing gas. Here it shows +1 state. NO +2 state. N2O3 +3 state. Initially NO2, that dimerizes to form N2O4, which shows +4. Then finally N2O5 +5. Nitrogen forms a series of oxide. The oxidation state changes from +1 to +5. These two are neutral oxide and others are acidic. Next, why NO2 undergo dimerization? Why NO2 undergo dimerization? NO2 undergo dimerization because it contains odd electron or unpaired electron. Odd electron or unpaired electron. Next, briefly outline the different steps involved in the manufacture of nitric acid. Nitric acid, it is also called oxo acid of nitrogen. The oxo acid of nitrogen is prepared by Ostwald's process. It involves 3 stages. It involves three stages or three steps. First one, ammonia oxidizes in presence of air to form nitric oxide. Nitric oxide further oxidation gives nitrogen dioxide. Nitrogen dioxide dissolves in water to give nitric acid, structure of nitric acid. Then concentrated nitric acid is a moderately strong oxidizing agent, and write any two reactions to show the oxidizing action of nitric acid. Then complete the reaction. Cu plus HNO3, here in bracket concentrated, as well as Cu plus HNO3 dilute. 3 Cu plus 4 HNO3 gives CuNO3 twice plus 2NO plus H2O. Here Cu plus 8 HNO3, when it is dilute, CuNO3 twice plus NO2 plus H2O. Okay. Then write a reaction to show the oxidizing power, or write a chemical equation to reveal the oxidizing action of nitric acid in the case of non-metal. Or it oxidizes carbon to carbon dioxide, iodine to iodic acid. HiO3 is iodic acid. Explain Brown ring test. Brown ring test. That is, here equal volumes of salt solution is prepared with a freshly prepared ferrous sulfate solution. Then concentrated sulfuric acid is added slowly along the sides of the test tube. Then a brown ring is formed at the junction of two liquids. It is due to the formation of nitrosoferrous sulfate or penta aqua nitrosonium iron 1 sulfate. Give the uses of nitric acid. Nitric acid is mainly used for cleaning the surface of metal during metallurgical operation. It acts as an oxidizer, laboratory reagent, and also used for the manufacture of some ammonium nitrate, fertilizers, manufacture, etc. And that's about group 15 element. And the phosphorus part, allotrope of phosphorus, compounds of phosphorus, even acids are deleted. And the next group is group 16 element. Group 16 or 16th group element. Group 16 elements are oxygen, sulfur, selenium, tellurium and polonium. These are 16th group element. They are called chalcogens. Chalcogen means ore forming elements. And we can say that the important source of sulfur. Sulfur is mainly present as galena. Galena is PBS. Cinnabar is HGS. Copper pyrites, CuFeS2. Then baryta, that is barium sulfate, gypsum, CaSO4 2H2O is gypsum. This CaSO4 2H2O is gypsum. Okay. Then chalcogens are ore forming elements. Ore forming elements. The compounds of a metal found in the earth crust are called minerals. Those minerals from which metal is extracted conveniently is called ores. That is why this group of elements are called chalcogens, ore forming elements. And about these elements, These elements combines with hydrogen to form hydride. Here, hydride of oxygen is water, H2S, H2SC, tellurium hydride. Polonium is a radioactive metal with a short half-life. And by analyzing the physical state of H2O and H2S, you can say that H2O is a liquid while H2S is a gas. H2O is a liquid while H2S is a gas. You have studied in lower class, that is, in water molecule, strong intermolecular hydrogen bonding is present. Therefore, H2O is a liquid while H2S is a gas. This is due to the presence of intermolecular hydrogen bond in water molecule. Intermolecular hydrogen bond in water molecule. And sometimes question, acidity, arrange the following hydrides of 16th group in the increasing order of their acidity. Acidity means the tendency with which it replaces hydrogen. As we move down the group, what happens? The bond becomes weaker, hydrogen and that corresponding element becomes weaker, hydrogen can be easily removed. H2O is least acidic, H2S, H2SC, H2TE is the strongest acid. And all these elements forms oxide, combines the oxygen, they form oxide. Sulfur mainly form two types of oxide, one is dioxide and other is trioxide. And also with the halogen, they form different types of halides. Oxygen combines with the fluorine because fluorine is more electronegative that element to form OF2 and O2F2. Among this, OF2 is stable. Only in OF2 oxygen shows +2 oxidation state. Only this is stable at 298 Kelvin. And as far as this allotropic form is concerned, oxygen and sulfur mainly form allotrope. Allotropes of oxygen are normal oxygen or dioxygen and ozone. Dioxygen and ozone. Sulfur forms different types of allotropes such as rhombic sulfur or alpha sulfur. Second one, monoclinic sulfur or beta sulfur. Alpha sulfur, beta sulfur, then plastic sulfur, it is the amorphous form of sulfur, and fourth one is about colloidal sulfur. Gamma sulfur, delta sulfur, but these two are included in our book. Only rhombic sulfur, which is the stable form of stable allotrope of sulfur, is rhombic sulfur. It is a dull yellow or pale yellow colored solid, stable form. And monoclinic sulfur, it is a needle shaped crystalline form of or crystalline allotrope of sulfur, which is obtained by taking rhombic sulfur in a china dish. It is melts and cooled till a crust is formed at the surface. Rhombic sulfur is taken, on heating it melts, and after cooling a crust is formed at the surface. Two holes are made on the crust and the remaining liquid is poured out. Then we get needle shaped monoclinic sulfur. And at a temperature called 367 Kelvin, above 367 rhombic sulfur is stable, and below 367 monoclinic sulfur is stable. and at 367 Kelvin, both the forms are stable, both allotropes are stable. That is called a transition temperature. Transition temperature. Both monoclinic and rhombic sulfur are crystalline form of sulfur. They are arranged as crown shape. Arranged as crown shape or puckered ring structure. Crown shape or puckered ring structure in the form of W, or it is arranged as a chair form as S6 molecule. Chair or crown shape, crystalline form of sulfur. And next we discuss about dioxygen. Dioxygen, that is O2. While we are explaining the manufacture of nitrogen, air constitutes 78% nitrogen and 21% of dioxygen. On cooling we get liquid air. That liquid air mainly contains dioxygen and dinitrogen. Dinitrogen distills at 77 Kelvin and dioxygen distills at 90 Kelvin, 90 Kelvin. This dioxygen is manufactured or prepared on a large scale by the fractional distillation of liquid air. And you know, this on a small scale, dinitrogen is prepared by the decomposition of metal chlorate. Metal chlorate such as potassium chlorate on decomposes to give 2 KCl plus 3O2. 2 KCl plus 3O2. And similarly, manganate 2 KMnO4 decomposes to give K2MnO4 plus MnO2 plus O2. Oxygen is released. Electrolysis of acidified or alkaline water. Pure water is a bad conductor of electricity, therefore acidified or alkaline water, when it is subjected to electrolysis, oxygen gas is liberated at the anode. These are the preparation of oxygen. Then oxygen, colorless, odorless, tasteless gas. It exists in three isotopic form. It can react with a metal, non-metal, or even certain compounds also. Oxygen react with a metal. It react with aluminum to form aluminum oxide. Sodium to form sodium peroxide, lithium monoxide, magnesium oxide, metal reaction with the metal. Mg plus O2 gives 2MgO. And the dioxygen can react with the non-metal also, hydrogen or nitrogen at a high temperature. It forms oxides of nitrogen, water, etc. And reaction of a substance, complete reaction of or burning of a substance with oxygen or in air is called combustion reaction. You know, all hydrocarbon on complete combustion gives complete burning in air to form carbon dioxide and water. They form carbon dioxide and water. Next category is about oxides. Oxide. Oxides simply they are binary compounds of oxygen. Binary compound means oxygen combines with other elements of the periodic table to form a secondary compound that is called oxides. That is simply oxides are binary compounds of oxygen. Then oxides are of different types. One is acidic oxide. Acidic oxide means those oxides which react with the water. Oxygen combines with other elements to form oxide. All the secondary or binary compounds of oxygen is generally termed as oxides. Those oxides, the oxide formed by the combination of oxygen with other elements, which further treated with water to give an acid, such oxide belongs to the class of acidic oxide. Clear? Oxygen combines with other elements of the periodic table to form oxide. When this oxide combines with water to form acid, they are called acidic oxide. And example of this acidic oxide, carbon dioxide, sulfur dioxide, etc. Carbon dioxide reacts with water to form H2CO3 or carbonic acid or soda. Then second one is basic oxide. Basic oxide means those oxides which react with the water. Calcium combines with oxygen to form calcium oxide. This calcium oxide reacts with the water to form calcium hydroxide. It is basic oxide. Third one is amphoteric oxide. Amphoteric oxide. Example ZnO, Al2O3, etc. Certain oxide can react with acid as well as base. ZnO plus 2HCl gives ZnCl2 plus H2O. ZnO plus 2NaOH. ZnO plus 2HCl gives ZnCl2 plus H2O. ZnO plus 2NaOH gives Na2ZnO2 plus H2. Okay, that is they belongs to the class of amphoteric oxide. And there is one more category, that is oxide which can neither react with acid nor base. They belongs to the class of neutral oxide. Neutral oxide, that is NOCO, etc. Neutral oxide. Once more I repeat, oxides are binary compounds of, here oxides are binary compounds of oxygen. Binary compounds of oxygen. And these oxides are divided into, one is acidic oxide. Those oxides which react with the water to form acid are called acidic oxide. Second is basic oxide, react with the water to form base. Amphoteric oxide, react with that particular oxide can react with acid as well as base. And the fourth one is neutral oxide. These are the 4 types of oxides. Okay, and next we move to the allotrope of oxygen, that is ozone. That we will discuss in the next class. Okay, thank you.